Hello guys, welcome back to the channel. So let's continue our GFG POTD series. We have already completed four of our days. So the today's problem says modified game of Nim. Let's see what does the problem say. The problem says you're given an array A of n elements. There are two players, player 1 and player 2. A player can choose any element from an array and remove it. If the bitwise XOR of all remaining elements equals 0, then after remove equals 0 after removal of selected element, then the player loses. Find out the winner if the player one starts the game and they both play their best. They both play their best is a is a important thing here, and this is also important thing. The equals 0 after removal of selected element. Okay, let's see what does the problem say. It says that we have been given an array A. Okay, now it says that there are two players, player 1, player 2. All right. Alternate turns, pretty evident. Okay. Player 1 moves first. Now, what does a turn correspond here? In a turn, player has to choose a number. Let's suppose he chooses this index. Now, if bitwise order of this, this, and this is equals to 0, then the player loses. Other player wins. I hope I am clear what I'm saying. Okay. So, three things to be noticed here. Best attempt. That is, the player is not using any guesses. He's importantly visualizing that what move would be best for him. Okay. Second means the player is also a good engineer because he knows what does the bitwise or also means. Okay. Second thing it says that bitwise or, which is a difficult thing to handle in coding without enough practice or of course. And third thing should be seen from the example here. It says the example here says that n equals to 2, array equal to 3 comma 3, but then also the answer is 1. How? It says that since the XOR of an array is already 0, 3 or 3 is 0, because we know that any element XOR with itself is 0. Since the XOR of an array is already 0, player 1 wins. So this gives me two conditions, that if already 0, player 1 wins. Else already not equal to 0, that is the condition here. What do we have to do? Now, I say there is a simple thing. Okay, let's see what I'm saying. I'm saying that until length is not equals to 0, run a loop. Okay, this is loop 1. Okay, I say in each loop, do one thing, traverse the remaining array and choose an element which, after removal, does not make you lose. Now, if there is no such element, then you lose. Okay, or if the array becomes empty, then you lose. Otherwise, turn changes. Pretty obvious. Okay, don't take it very hard on yourself. It is a very simple problem if approached correctly. Okay. Now, what are the conditions? That if there is no element existing, then you are losing. If the array has got an empty, That is, there is no that is what I'm going to say, that uh, if after, like, suppose you have two elements, or if you have a two element case now, okay, the array contains two elements, okay, a comma b. Suppose player 1 removes a, okay, player 2 removes b. Now it says that after removal of b by the player 2, the array becomes empty. Now the question is treating the XOR of an empty array as 0. If you see by the examples, it says for the 332 case, optimal removal of value is 3, then 2, then 3, becomes the array as empty. That player 1 remove 3, player 2 remove 2, player 3 remove 3. Okay, player 2 remove 3, then the array becomes empty. So the player 2 wins. What I'm saying is player 1 remove 3. Alright. Now player 2 remove 2. Now player 1 remove 3. After removal of third element, the array becomes empty, and then we are treating the XOR of an empty array as 0. So player 1 has given the array which bitwise XOR is 0. So player 1 is losing and player 2 is winning. Alright. Very simple. Okay. So three conditions are clear to us. I say that choose an element which after removal doesn't make you lose. Okay. Now, I think this is the only pseudocode you have to implement in your coding skills. And I think if you are not a coder, if you cannot convert a pseudocode into the code, also I will help you now. Okay. First, let me write you the pseudocode. Okay. I say run a while loop while length is greater than 0, and then traverse. Okay. So time complexity would be O of n, and this one is O of n. It would give rise to O of n square, and space complexity is O of 1. Is pretty good because we are not using any extra space to sort the array or anything like array or map or set, etc. So O of 1 is the case here. Let's come to the code. First, I said that declare a variable to calculate the bitwise OR of the initial element. Now, if the bitwise OR is already 0, return 1. Then the player 1 gets. Else, what we have to do, I'm using a variable count here, which is initialized by 0, and in turn equals to 0. I will explain why. Now, while I say that while count is less than n, okay. Now, what we were doing? We were doing the traversal. For int I equals to 0, I goes up till n minus 1, I plus plus. Now, what I'm doing is that to remove an element, it would take a complexity of O of n because we have been given an array. Also in vector also it will take the complexity of O of n. I'm saying that what you should do, just because we are given in the constraints that array of I is greater than or equal to 0. So what if we convert that element which we want to remove into minus 1? So next time we encounter that element, we will understand that if it is minus 1, this element has already been removed and we don't have to do anything for it. So whenever we convert an element into minus 1, we increment the count. Now whenever we increment the count, the length decreases by minus 1 implicitly. So I'm using minus 1 to execute the length statement. Okay. Now what I have done, that if first calculate the x element, int x equals to array of I XOR answer. Okay. Now what if array of I was not valid to be executed above statement? If array of element I equals to minus 1, then simply continue. Else, if if condition was to choose an element after removal doesn't make you lose. Now there are two things to do, two approaches to do this thing. We have to choose an element. Okay, we have to choose an element. Now this can be done like traverse the array and calculate XOR of remaining, but that would take a complexity of O of n, and our overall complexity will become O of n cube. Non-efficient. We do not basically discard it. Second thing we can use is, suppose what in answer, what, like suppose array was A B C D E. So initial answer was holding A XOR B XOR C XOR D XOR E, correct? If I choose to remove C, then this is the XOR of the remaining array. So is there any step that can lead me to answer after updating in O of 1? Here comes the role of XOR. So XOR's inverse property says the XOR of it, XOR's inverse is XOR only. That is, that if A XOR B is equals to C, then A is equals to B XOR C. Important property, remember, may be helpful in solving the bitwise operator questions in the near future. So what we have to do here, we want answer XOR C, and we know that answer is A XOR B XOR C XOR D XOR E. So let us treat this as X. So X XOR C is answer. So then X is equals to answer XOR C. So to calculate the remaining bitwise, we just have to do answer XOR C. All right. Okay. So here, what we do, this is the AI XOR answer. That is why I written AI XOR answer only here. That if X is not equals to 0, then only we can remove that element. So what are the steps we have to do now? First, change answer into X, because after removal it will become the X only. Okay. Change AI to -1, and because we change AI to -1, we have to increment the count. Okay. And now, how will we remember after the loop that there was an element we removed? So we have, I'm keeping a check here. In check equals to 0. If this happens, then check it will become equals to 1. And if that has happened, we have to change the turn. So we break out of this loop. Now what would we do? Now if check equals to 0, that means the player was not able to turn, not able to execute his turn, so he loses. So what we do here, we just use a break statement and handle that query afterwards. That now what if player has executed his turn, so we have to change the turn. This would change 0 to 1 and 1 to 0. Okay, no problem. After the loop has executed, now if turn equals to 0, that means player 1 has to execute his turn, but is not able to execute. That means player 2 has win, because player 1 has lose in this condition. Else, return 1. Let's see if it works. We have not committed any error. Oh, we have committed any error. It says before 4. Yeah, we have not applied semicolon here. I hope this was the only mistake I committed. Yeah, it is working for compile and run. Now submit. Now I tell you that this is not an efficient approach. See, it will give it a TLE. We have been given a expected time complexity is of n. So there is an interesting way to do this problem in O of n. Okay, this approach is also very good. The interviewer might be impressed by this approach because it is using the property, this property. It shows that you have been studying about the XOR operator. Okay, but how do we do it more efficiently? Let me clear the page for you. So let's come to the comes down to the proper the initial start. Okay, what we were given an array a B C D E. This was our array. Now we done that answer equals to 0. That is the initial bitwise or is equal to 0, done 1. Else, now if the initial or is not equals to 1, and suppose length of the array was 1. Okay, so what option does player 1 have? Player 1 has no option, none other option than removing 1. And if he removes 1, the array becomes empty and the bitwise or becomes 0. So bitwise or becomes 0, so player 1 loses. So who wins? Player 2. Okay, this was for condition n equals to 1. I'm using the, try to think that I'm using the length as a key factor here. Okay, it is a very simple problem, but a tricky one. Okay, if the length is 2, n equals to 2. Okay, A, B. Player 1 removes A, player 2 removes B, and then player 2 removes B, and that array becomes empty, and player 1 wins. Okay. For n equals to 3, A, B, C, player 1 removes, player 2 removes, player 1 removes again, array becomes empty, 1 loses, 2 wins. So I'm able to see a pattern here that for 1 and 3, 2 wins, for 2, 1 wins. Now, if for n equals to 4, if 1 is winning, then there is a certain pattern that 1 2 1 2 1 2 1 2. Okay, so A, B, C, D. Player 1 removes, player 2 removes, player 1 removes, player 2 removes. Player 2 removes, array becomes empty, player 2 loses, player 1 wins. So I'm able to see that whenever n is odd, 2 is winning. And whenever n is even, 1 is winning. Same is the case here, same is the case here. Now let me make you understand how. The reason is we have been given that they try their best. That is, they make optimal choices. And any optimal choice will lead them to the winning only if n is favorable to them. Okay, so n is the key here. Okay, I hope it is very much clear. It might be confusing that what if the answer does not depend on n, and if there is a test case that after removing it may lead to 0, but that is not possible. You can try any of your test case, any of the test cases you want to. That is not possible. N is the only key here. So what we have to do? This up till here we are correct. We have to execute case one. N is the key here because if it was have given 0 for any subarray, then it would have given 0 here only. And in that case, player 1 is winning. Okay. So now only true statements if n percentile 2 equal to 0, that is for even case. What is for even case? We have to return 1. Else we have to return 2. Let's compile and run it. Running fine. Let's try to see the submit button. It has been worked. Okay guys, thank you for watching the video. Hope you liked it. Please don't forget to like and subscribe. See you in the next video. And congratulations, a current streak is 5 days. We have been doing it consistently for 5 days, and we will be doing it consistently for the rest of our lives. Thank you. Bye.